Most people think an information system is just software. That's wrong. Software is only one part of the system. A real information system is made of different components working together. If one part is weak, the whole system becomes weak. The most common components of an information system are hardware, software, data, people, processes, and networks. Let's break this down simply. Hardware means the physical devices used in the system. Computers, servers, barcode scanners, payment machines, tablets, phones, routers, and storage devices. In a restaurant, the POS machine, kitchen display screen, receipt printer, and tablet used for QR orders are all hardware. Without hardware, the system has no physical body. Software is the set of programs that tell the hardware what to do. This includes apps, operating systems, databases, dashboards, CRM tools, ERP systems, inventory software, and cloud platforms. In simple words, software is the brain that runs tasks, processes orders, stores records, and shows reports. But software alone is useless without data. Data is the raw material of every information system. Customer names, sales records, product prices, stock levels, employee shifts, payments, feedback, and delivery times, all of this is data. But raw data by itself has little value. The real value comes when the system organizes it and turns it into useful information. For example, 100 burgers sold today is data, but burgers sell 40% more on weekends. So we should prepare extra stock that is useful information. Then comes the most ignored component, people. People are the users, managers, employees, customers, IT teams, analysts, and decision makers who interact with the system. A business can buy the best software in the world, but if people do not enter data correctly, follow the process, or use the reports, the system fails. That is why people are not outside the information system. They are part of it. Next comes processes. Processes are the rules and steps that tell the system how work should happen. How is an order placed? Who approves a refund? When is stock updated? How is customer feedback handled? How does a manager review sales? These workflows make the system useful. Without processes, technology becomes chaos. A POS system without a clear order process creates confusion. A CRM without a follow-up process becomes a contact list. An inventory system without stock rules becomes unreliable. A dashboard without decision rules becomes decoration. Then we have networks. Networks connect the system. Internet, Wi-Fi, cloud connections, internal networks, APIs, and communication links allow data to move between devices, departments, branches, suppliers, and customers. Without networks, modern information systems cannot work in real time. Think about a simple online food order. The customer places the order from a phone. The system sends it to the restaurant. The kitchen sees it. The payment is confirmed. The delivery rider gets the address. The customer receives updates. All of this happens because hardware, software, data, people, processes, and networks are working together. That is the real point. An information system is not one thing. It is a combination of components. If the hardware is outdated, the system becomes slow. If the software is poorly designed, users get frustrated. If the data is inaccurate, decisions become wrong. If people are not trained, the system is misused. If processes are unclear, work becomes messy. If networks are weak, the system becomes disconnected. This is why businesses should not ask only, which software should we buy? They should ask, do we have the right components working together? Because a successful information system is not about having the most expensive technology. It is about alignment. The right hardware, the right software, the right data, the right people, the right processes, the right network, all working toward the same business goal. At the Learning Studio, the goal is simple: to help you see information systems as complete business engines, not just technical tools. Because once you understand the components, you start seeing why some systems succeed, why others fail, and why technology alone is never enough.